So in constructing confidence intervals, I do want to do an example of doing a confidence interval for variance. So for variance, we do have to use what's called a chi-squared distribution. So we need to know how to deal with that. So remember a chi-squared distribution graph, remember here's zero over here. So not like Z and T where you have negative and positive and you have symmetry there. Chi-squared distribution kind of takes on a skew to the right. One nice thing to know though is the area to the left of chi-squared L is going to represent the same area as the area to the right of chi-squared R. So we need to identify these two critical values, chi-squared L and chi-squared R. Now, we were doing it with the table, but this time I want to use Excel to kind of work out this problem. So in this problem, we have randomly select and weigh 30 samples of allergy medicine. The sample standard deviation is 1.20 milligrams. So remember, standard deviation is how far we vary from the mean, but they don't give us the mean at this point. So we have 30 samples and we know that the standard deviation is 1.2. So assuming that the weights are normally distributed, construct a 99% confidence interval for the population variance and the standard deviation. Now remember the confidence interval, we have this formula, n minus 1 times s squared divided by chi squared r. So the variance is going to be in between then that and n minus 1 times this s squared divided by chi squared l. Now remember n minus 1 is degrees of freedom and s squared is the sample variance. And remember sigma squared is the population variance. So what we're trying to figure out is with a 99% confidence interval, how confident are we that the variance is going to be between these two values here? So some things we need to pick up on is one is I need to know the sample size, which is the 30, because it's going to help calculate the degrees of freedom. So degrees of freedom would be n minus 1, or in other words, 29. Now, the other thing is the level of confidence. So a lot of times we'll use C for the level of confidence. That's going to be 99%. The other thing we have is the sample standard deviation is 1.2. So the standard deviation is 1.2. So what I want to do is take this to Excel and kind of determine what the confidence interval is for this example. So in this example, notice how we said the level of confidence was 99% or 0.99. We said the sample size was 30 and the sample standard deviation was 1.2. Now remember, to do this problem, our formula is n minus 1 times s squared over chi squared r is going to be less than the variance squared, which is going to be less than this n minus 1 times s squared over chi squared L. So this is the given information. But notice right off the bat, though, we have to do a few little things here. Now, one of the things to do this on Excel, we need to know the area to the right or left of the level of confidence. Now, remember the level of confidence is actually the area between chi squared L and chi squared R. So the level of confidence is actually this region here. So what we need to do to start with is find the area to the left and to the right of the level of confidence. So to do that, what we can do is go 1 minus the level of confidence. So we can make a formula that says the area to the right left is going to be 1 minus the level of confidence. So 1 minus then, and I'm just going to put this in here to create a formula. So 0.01. Now to use Excel, we need to know the area to the left. So this area here that's left and right has to be divided by 2 to get to the area to the left. So if I hit equals, what I can do is this area then has to be divided by 2 to get the area to the left. So we end up with this 0.05. Now, another thing we need to know is the degrees of freedom. Now, remember the degrees of freedom is going to be the sample size minus 1. So using a formula, I can say equals, and I can say the sample size 30, which is in cell D4, I can subtract then 1, and that'll give me the degrees of freedom. Now, chi-squared L, remember that's that test statistic, that sample critical value, I should say. So to find this critical value chi-squared L, and again, I'm just going to use this notation here, chi-squared L. To do that, there is a formula inside of Excel. So if I hit equals and I start typing chi, notice how to get the actual critical value to do L, what we use is this chi-squared inverse. Chi-squared inverse will give us the chi-squared L. So what it needs to know is the probability, and what it needs is the probability to the left. So it needs this 0.05 here. So this goes in, that's the probability. And then also it needs, let's try that again. So I need this area to the left. And also I need to know the degrees of freedom. Well, the degrees of freedom would be in this cell here. So notice how I'm creating a formula. So if I enter, that'll give me my chi-squared L. To do chi-squared R, to get that critical value, again, we can use a formula. We can type in this chi. But notice how this time it's going to be chi-squared inverse right. So we need to do this one to do chi-squared R. It still needs this area. Remember, to the area to the left and the right are the same, so the probability is going to be the same there. So I choose that D8, same area. And the degrees of freedom is still going to be this 29. So if I close that parenthesis and hit enter, it'll do my chi-squared L. Now to do the confidence interval, to do the left side, we have this formula. Now to do this formula, though, we still need the sample variance. So let me come up here and put in uh, the sample variance. So sample variance. So the sample variance is actually going to be the sample standard deviation squared. So if I hit equals, I could choose that cell and raise that to the power of 2. So there's a little above 6. There's a little caret there. That's squares. Hit enter. So there's the sample variance. So 1.44. So what I can do now, if I can come down here and so what I need is my degrees of freedom and my sample variance. So if I come here, hit equals, and since this is in the numerator, I'm going to use parentheses. So in parentheses, my degrees of freedom is in this cell, and I got to multiply that by my sample variance, which is in this cell. And then I have to divide that by chi-squared R, which is in this cell. So close parentheses. I can hit enter. Let's see what I got here. Try that again. You pause for a second here and see what's going on. So let me try to type that in again. So chi-squared, I need the degrees of freedom, so that's going to be this cell, times then the sample variance, which would be this cell. But again, I do want that in parentheses. Parenthesis there, parenthesis there. And then I just want to divide it by chi-squared r, which is this cell. So if I enter, that gives me my confidence interval to the left. Now to do my confidence interval to the right, I hit equals. Again, I want this in my numerator, so I'm going to use parentheses. So my degrees of freedom would be the 29, that cell. I got to multiply by the sample variance, which is here. And then if I divide that by chi-squared L, which is in this cell, that'll give me my confidence interval. So from there, I could then say, if I round to 3 decimal places, my confidence interval would be 0.79. So that 7 there is going to move to an 8. So 0.798, oops, 0.798 is going to be less than sigma squared is less than, and then 3.182 or 3.183 if I go 3 decimal places. So notice how we do get our confidence interval. So we're 99% confidence that the population variance is going to be between 0.798 and 3.183. So notice how our sample variance was 1.44. So we're saying the population variance is going to be, with 99% confidence, is going to be between these two values. Now, to do the standard deviation, remember we have to take the square of these two values. So if I hit equals and type in SQ square root, I could then choose cell D14, and that'll give me my standard deviation interval piece. And if I hit equals there and do square root again and choose the right one, close interval, notice that gives me my confidence interval for standard deviation. So for my standard deviation, I would be saying, 0.893 is less than, and then 1.784. So that would be my confidence interval. So I'm 99% confident that I'm between there. Now remember, we also could be using interval notation. So I could be saying 0.893 to 1.784 if I was using a confidence interval. Now, what's nice about this is if I change my confidence level, to say 90%, if I enter, notice how by creating formulas in Excel, it does all the math for me. So if my sample size and standard deviation had changed, then I've got it. But so suppose we have a different example altogether where our sample size may be smaller or bigger. Let's say, we did say, a 12 is our sample size. And suppose our standard deviation was, say, 0.08. So if I change those three fields, notice that everything gets changed. Everything gets changed. So that's the cool thing about Excel is once you put in the given information fields, then you can build formula fields that will alternate and just adjust your thing as necessary. So some of the power behind building stuff inside of Excel is all you have to do is adjust a few different fields, and then the rest of the math can be done for you once you build it.